Hello and welcome back to Python and welcome back to Numpy. And yeah, what makes me a little bit sad is that this is the last video of the Numpy series. Maybe I will make another Numpy video if I realize I forgot something which is important. But yeah, as planned, this is the last video. And yeah, kinda hard to say goodbye, but yeah, so it is. Today we are gonna look at the random package of the package numpy. So for example, you have numpy.random, and yes, random, as a quick reminder, with random you can create your own random integer with the old random package, not the numpy random package. Like this. You can define a range, and then you will get random numbers between 1 and 4. Or you can just define a random float. And you can also define random choices of a list or of a sequence. And yeah, that was just a quick reminder. Now in NumPy, the random functions are much more complex, or can be much more complex. For example, let's first start with random.rand. So random.rand does, random.random, yes, random.random does the same as the random.random of random, because I imported random.random as from the numpy package does the same as from the random package. But, and here it gets interesting, we can define a shape. For example, if we use just a 4 as an argument, he will give us a one-dimensional array with 4 floating point numbers. And yeah, just keep in mind that the random only has one argument. For example, if we have 4, he will give us an error because he thinks I gave him 2 arguments, so giving him only 1. So we have to use extra brackets to tell him we are using a shape now. And now we got a 4.4 matrix, or just call it two-dimensional arrays for rows, for columns, and so on. We can do it 3-dimensional, 4-dimensional, and so on. And it's a simple and quick way to define arrays with certain numbers. If you want just an array for testing, you can just do random. And if you want random integers, you have, like in the random package, you have the randint. And because the arguments are slightly different, he now thinks we want a randint between, or a random integer between 0 and 4. I guess. Yes, excluding 0, I guess, but he gives us random numbers because he's interpreting the numbers differently. So this should give us, yes, I forgot a bracket. This should give us an integer between 0 and 4. This should define the shape. I guess we have to define the argument. I guess it was size. No? Oh, because I'm in the print function, that's why. So there we go. We got a two-dimensional array, but to Let's do it a little bit more interesting. Now this is a 4.4 two-dimensional array, 4 rows, 4 columns. Yes. And like before, we can even increase the number of dimensions. If we want to get things more messy, we can also use rand integers for the sizes. Now we are creating arrays with different sizes, and yes. Outcome can be quite interesting. Now let's add some deviation to an array, to an array. So let's print rnd point normal. Now we have a matrix where we can choose, we can choose the standard deviation, for example 0 or 2, which means we can have numbers from standard deviation of 2, and the size should be 10. And yes, of course it can be lower than 0, but the standard deviation is 2. It should be even higher than 4, should be possible. Yes, it is. By the way, they are floating point numbers. The normal function doesn't have dtype as an argument, but there are different ways to make integers out of it. And like in the random package, also Numpy random has seeds. Big difference, in the Numpy package he wants integers. And now it gets interesting, because we have to set the seed again if we want to use the same deviation. Also we are creating, or we are using a random function here and here. Of course, because we are using the random package, the size of our arrays will always be different. So if we are using Numpy random package, it should be the same size depending on the seed. Yeah, it is. Okay, and we have to set the seed again if the second array always have to be always the same depending on the seed. So here now it stays the same. Okay, that's interesting. Maybe it was the random package, but again, what I wanted to say is that you can set seeds like in the random package. But now I'm curious. So here he always creates the same array. Now let's switch back to random. Delete random seed. Now he switches. Maybe that's really interesting. If we don't use the random package, the seed of the Numpy random package also goes for the random normal, and I've learned something as well. Perfect. And strange. Maybe if you know what the issue is, you can write it down in the comments, but I wouldn't call it an issue. I would call it something nice I discovered. So for the next subject or topic, let's first create a list which contains three elements, and let's create possibility containing three floating numbers. or no, let's be more specific. What's just important is that the total number of the elements has to be 1. And now for our last act, let's create an array containing only these 3 strings with these, these are the possibilities, the percentage possibilities. Let me create an array, then you will probably know what I mean. So again, you have, like in the random package, you have this choice. Then you can say a one-dimensional array, which is listy. And then we create the size, which again is our tuple, the shape. And last but not least, let's do the possibilities. Look how it is called. It's just a p. P equals possibility. And let's print it. And here we go. Most of it's monk. We got an array containing monk. And do we have at least one ape? I saw one. Yeah, there's one ape. Let's do it again. Oh, here's one ape, but no monkey. Do we get a monkey? Come on. Here's another ape. Man, that's why I suck at casino games. Monkey, monkey, monk, monk, monk. Where's the monkey? I want a monkey. Here's an ape. Come on, monkey, monkey, monkey. Maybe you saw one and here's another ape. I won't finish this video until I saw a monkey. Ah, there's a monkey. Here we go. And that's it for Numpy and for random. I hope you had fun while watching my video and looking me searching for the word monkey. And see you on my new videos. It will take some time until I make a new Numpy video, but I hope you liked my series. I will make a supercut in a few days, and it will be about 1 or 2 hours. But for that, have a nice evening, dinner time, whatever time it is. See you on the next video. Bye bye, goodbye, and adieu.